Welcome to episode 100 of Paper Brief. I'm Charlie, your host, and today we're joined by Cleo, an expert in tech and machine learning. We'll be diving into an exciting paper titled Training Chain of Thought via Latent Variable Inference. Cleo, can you give us a quick breakdown of what this paper is about?
Absolutely, Charlie. This paper by Dufan and colleagues from Google focuses on large language models, or LLMs, and a technique called chain of thought prompting. The idea is to get LLMs to work out problems step by step, which tends to yield more accurate and interpretable answers.
Interesting. So, what's the main challenge with using the chain of thought method they're trying to solve?
Well, combining chain of thought with supervised tuning usually requires detailed rationales along with correct answers. But generating these rationales can be resource-intensive. So the authors propose a fine-tuning strategy that works by approximately averaging over all possible rationales instead.
So they're kind of bypassing the need for these expensive, manually created rationales.
Right? They're using a Markov chain Monte Carlo algorithm mixed with a neat control variate technique inspired by something called the self-taught reasoner and a few other concepts. Their technique helps sample from the posterior of rationales, which conditions on the correct answer.
How effective is this method compared to other techniques?
The results are quite promising. When applying their MCMC-EM fine-tuning to certain datasets, they found it improved the model's accuracy more effectively than other tuning methods, including the original self-taught reasoner.
That makes sense. Now, does this approach have wider implications for machine learning and reasoning?
It does, indeed. Since chain of thought is a form of latent variable model, this approach brings together several strands of research. It's applicable to learning with incomplete data, which is a central theme in probabilistic machine learning.
This definitely feels like it's pushing the boundaries. Can you imagine other applications or improvements stemming from this work?
For sure. The principles outlined here could be generalized to various types of question-answering tasks and could potentially be applied to improve natural language understanding in more complex or ambiguous scenarios.
Just one last thing. Can you tell us a bit more about the datasets they use to validate their approach?
They use the GSM-8K dataset and the Big Bench hard benchmark. Both datasets presented a variety of problems, and the technique showed significant performance improvements over classical methods.
Fantastic. Thanks, Cleo, for shedding light on this exciting development. That wraps up episode 100 of Paper Brief. We hope you enjoyed our deep dive and came away with some new insights into the future of LLMs and machine reasoning.